How the fuck can you tell if the angle between two vectors are acute, obtuse, or right? Bro, listen here. I'm going to show you today. So let's see. I don't even know what the title is going to be. Two vectors, acute, obtuse, and right. That's a good title. All right. So how can you tell? Well, in the previous video, we talked about dot product. If you didn't watch that and you don't know how, or if you don't know how to do dot product, go ahead and watch that. But basically, this is how you can tell if two vectors are acute, obtuse, or right off the dot product. So with a little quick recap on dot product, you multiply each corresponding point. So you have x1, and you add them all up together. y1, y2. That's an ugly ass y. And z1 and z2. If you have the z, they're dimensional, whatever, then you multiply them, add it up together. So after you get that, you get a whole number. After you do this, you get a whole number. Let's say the whole number was 5. This 5 means that the angle between the vectors is acute. So if we find the dot product, and then the angle is a positive number, it's acute. So acute is a positive number for the dot product. Positive dot. I'm going to rewrite that. Positive dot. If the dot product is obtuse, then it is negative. And if the dot product is, hold on, let me erase this. The dot product is right, then it is 0. Oh, the dot product will be 0. And I'm going to show you the reason why. So this is for understanding. If you just only need this information and you don't care about understanding your math, then go ahead and just end the fucking video here. But for the people that actually care, I'll show you how. So let's actually make all this smaller. The formula for a dot product is also, right, you have x1, x2 plus y1, y2 plus z1 and z2 is equal to some real number, right, r. But, or some scalar. But you can also get the magnitude of the two vectors times the cosine of the angle between the vectors. So look what happens. When the angle between vectors is acute, cosine, or anything less, when theta is less than 90, and you can do the math with all your cosines, you could put 89 cosine, it will be positive. It will be a positive number. Cosine will be a positive number. And magnitudes, remember, magnitudes are always positive. So we can ignore these for whatever is your negative number calculation or your answer. We can ignore these two values. We can just focus only on the cosine. So remember, these will always be positive. So I'll write that down, positive. Magnitudes are always positive. Magnitudes of vectors are just the length of the vector. So you can't have like a negative length. Where are you going with the negative length, right? Where would you even go? But when theta is less than 90, which means that the angle angle is acute when the angle is less than 90, the dot product will be positive. And the reason why is because cosine will be positive. So if these two have to be positive and cosine is also positive when the angle is less than 90, that means the angle is acute, and then your dot product will turn out to be a positive real number. Now, what happens if, let's say, cosine is equal to, let's erase this, cosine is equal to 0. Let's say theta is equal to 90. Sorry, not 0. Theta is equal to 90. Well, cosine of 90 is equal to 0 with your trigonometry or whatever you've done. But cosine of 90 is equal to 0. So if, let's say, two vectors form 90 degrees, their dot product, no matter what the magnitudes are, if you multiply any positive number or negative number by 0, it will turn out to be 0. So the answer for two vectors that form a 90-degree angle will always be 0. The dot product will always be 0. How about for obtuse? Well, let's do that. Oops. So what if the angle between the vectors is obtuse, greater than 90? Greater than 90 over here. What if they are greater than 90? Well, if the angle, I wrote down the wrong one. Hold up. The angle is greater than 90. If the angle is greater than 90 for cosine, you can plug in cosine of 91 onto your calculator, right? Or cosine of, I don't know, cosine of 179, right? The cosine will always be negative if it's above 90, or between 180 as well, right? Between 180. And the reason why I'm saying between 180 is because this is just a reminder for any of you guys that don't remember this. Whenever you have two vectors, you're measuring the angle. The angle you measure between them is always the shortest angle. What I mean by that is you're going to measure this angle. You're not going to measure this wide angle over here. And even if you have two vectors that are facing like this, you're going to measure the shorter angle. You're not going to measure this one. So the angle between the vectors cannot be greater than 180. So let's say we have an angle greater than 90 between 180. And that's the same for theta. When it's like theta, for the acute angles, theta has to be less than 90, greater than 0. But let's say we have an angle between 80 and 90 between the two vectors. Well, cosine of any theta between these values right up here, between these values is equal to a negative number or some x or something like that. I don't know. I'll just represent it with the real number. I think this is a real number symbol, I hope. It's going to be any negative real number. All right. So that's just it. If your dot product is positive, then the angle is acute. If your dot product is negative, then the angle is obtuse between the vectors. And if your dot product is 0, the angle is right. So both of these ways you do this, the magnitude is times the magnitude of one vector, each vector, times the cosine of the angle between, will give you the same result as this one down here when you multiply just the components of the vectors. So you can just literally lazy method do this one. This one's way easier. If you can do this method, do it. And if you get the dot product of a positive number, right, out of this right here, if you get the positive number in this answer for the dot product, then your angle is acute between the vectors. If you get a negative number, angle's obtuse. If you get a 0, then the angle's right. Thanks for watching. If you guys have any extra questions, put it down in the comments section.